So of these cross sections, I think the most interesting one is actually number 1. So if you take a donut, I don't know if you've ever eaten a donut. I feel like it's an experience everyone needs to have at least once. But if you've eaten a donut and you know that it is almost, let's pretend, almost like a cylinder with a hole in the middle, of course. So when we cut through that donut, I wouldn't say a cylinder, I would say more like a sphere. But anyways, you can't really name it. When we cut vertically through that donut, we're going to get a cross section that looks like that. That's different. We didn't have any like that yesterday. All of ours was just like one shape. Now, depending on how your donut is, I guess if you wanted it to be more cylindrical, I guess your cross section could have been kind of more like that, or I guess more like a rectangle possibly, depending on what kind of donut yours looked like. But it would be two shapes kind of like that, right? All right, number 2, for the celery, should have gotten something like that, or you might have done it going the other way. I don't really care which way that's oriented, but you should have done something that was like a kidney bean. All right, number 3, now on these two, 3 and 4, we're going to slice it horizontally. Horizon, like parallel to the base, I guess, if they have bases. So if I were to slice through this horizontally, then the cross section is going to be like that. As long as we are making sure that we're not counting that frame, the middle frame in the middle. Okay? And number 4, finally, what would your shape look like for number 4? Is that what you got for number 4? But it's not a triangle, and that's really important, right? It's not a triangle. That's actually called a sector, but we're not there yet in our geometry curriculum. Yeah, good. So it's not a triangle, because remember, a slice of pie comes from a circle. And so that is not, this right here is not a segment, it's an arc. It's a curve. Yeah. You're like saying everything I'm saying. That's funny. So those are what our cross sections would look like. Kind of different, a little bit branching out from what your homework was a little bit. Today's lesson is cylinders. Today's lesson is going to be really easy because now that we've already taught prisms, a cylinder is just a prism with circular bases, right? So a cylinder is not a prism. Because by definition, a prism has to be made up of like polygons. They have to have sides. They have to be segments. So they are in their own class, but a lot of their formulas are the same. The same. A cylinder is a solid with bases that are congruent circles. I doubt you have to write this down because I bet you already knew that walking into my class. So I'm going to move on. A cylinder has less variables to deal with. You don't have to worry about the base changing all the time. You don't have to worry about slant height. You've got an R and you've got an H, and that's all that you have to work with, the R and the H, the radius and the height. So there's not very many ways we could trick you here. You're not going to be using trig. You're not going to be using Pythagorean theorem. We're going to either give you D or R or H. You know what I mean? You're going to have most of what you need. So that's what's neat about a cylinder. Let's talk about where these formulas come from. So what is the lateral surface area of a prism? So for a prism, it's P times H. But circles don't have perimeters, right? Circles have circumferences. So the circumference of a circle is 2 pi r. And then we got our H. So do you see where that formula comes from? It's really perimeter times height, where this is the perimeter, and this one is, of course, the height, H for height. So the prism and the cylinder formulas are really just the same, but we have different formulas for cylinders because we get to tailor it to a cylinder because a cylinder's base is never changing. It's always a circle. The total surface area. So for a prism, it's LA plus 2B. Well, for a cylinder, it's LA, which is 2 pi RH, just to let you know. It's 2 pi RH plus 2B. Well, the base is always a circle, so the base is always pi r squared. So it's LA plus 2. B is always pi r squared. It's never changing. And the volume. Volume of a prism, base times height. And on your formula chart for a cylinder, it also just says base times height. So you have to go above and beyond and know that the base is a circle, therefore the base, its volume, or sorry, its area is pi r squared. Pi r squared h. Volume is always the easiest one to me. Let's try a super basic example. I'm not trying to trick you on anything here. I gave you the diameter and I gave you the height. Go ahead and compute those things. The beauty of these formulas is all you need is an R and an H. We were given the height. We were practically given the radius. We just had to take the diameter and, of course, divide by 2. So really all we're doing on this problem is we are plugging and chugging, right? We are going to keep our answers in terms of pi. So the lateral surface area, while you're still getting used to the formulas, I would write it out first. 2 pi r h. I would write it down with just the variables, then I would start plugging stuff in. So I'm going to skip over the pi when I'm in my calculator, and then I'm going to multiply back by pi at the very end. So I'm going to type 2 times 12 times 16. 2 times 12 times 16. 384 pi inches squared. Now, do keep in mind and remember that on the test, when you had those multiple choice questions, a lot of the answers were not in terms of pi. They were not exact. A lot of the multiple choice answers were approximate. So I don't want to go exact all the time, every time, and then you don't know how to approximate your answer. But you know that all you have to do to turn that into a decimal is actually multiply it out, right? 384 times the pi button. And so if you see on the multiple choice questions on the test, if you see decimals, you need to know how to get your answer to a decimal. Those are the same number, but one of them is more precise. This symbol right here, our calculus teacher at our school says they use that symbol a lot. They use equal for when it's exact, and when they rounded it, they use that symbol, which means approximate. That symbol means it's not equal to, it's approximately 1,206. Okay, let's move on. Surface area. We know that the surface area is what we already found is the LA plus 2B. Oh, I didn't mean to do the H. Sorry, 2B. There we go. So we're going to add 384 pi to double the area of the base. Now, those are both going to be pi's. They're both in terms of pi. So we are allowed to add them. Good. Okay. So it is going to be 384 pi plus, let's see, pi r squared, 2 times 12 squared. Since those are like terms, we are allowed to add them. 672 pi. Could we put that in our calculator and come up with a decimal? Yes, we could, but we're going to keep going. Volume, base times height, pi r squared times height. 144 times 16, right? 2,304 pi. You forget the pi, you get it wrong. So as a decimal, that would be what, 7,238? Okay, let's move on. Example 2. The volume of a cylinder is 160 pi. If the height is 10, what is the lateral area and what's the surface area? Let's save some time. Let's just find the lateral area. This is one of those work backwards problems. The best way to start is write down the answer to the problem and then write down what formula it's equal to. That is the volume. So I'm going to write down the volume formula. Base times height. Pi r squared times height. So that's how I begin. You set what you're given, the information you're given, to the formula. Set them equal. Now I'm going to plug in what I know. I know the height. I know it's 10. So I'm going to plug that in. We only have one variable left, and that's how we like these problems. One variable. We're going to start to simplify this. I can divide both sides by pi, which means I'm really just canceling out pi. I can divide both sides by 10. You know this drill. Oh, how beautiful is this? Whoa, 16 is a perfect square. Yay, we don't have to simplify a radical. R is 4. We don't say it's plus or minus 4 because radii cannot be negative, okay? So the radius is 4. Now we can find the lateral surface area. 2 pi r h. 2 times pi times 4 times 10. 80 pi, or as a decimal, I hate decimals, but I'm doing it more often because I noticed so much of your multiple choice had decimals. So it made me nervous that y'all weren't, that I hadn't trained y'all to know how to go from exact to approximate. Example number 3, last problem, we'll take that quiz. You need to paint 25 tin cans with gold metallic paint to be used for wedding centerpieces. Aren't those beautiful? I thought those were so pretty. The diameter of each can is 4 inches, and the height of each can is 8 inches. If a pint of metallic paint covers 100 square feet, how many pints do you need to buy? All right, what type of formula would we need to use for this wedding problem? LA, SA, V, what do we need to find? What data do we need to gather? Thank you for answering. Very good. We need the lateral surface area. We don't need to paint the bottom because no one's going to see the bottom. Hopefully people don't pick up the centerpieces and look at the bottom, right? So we're only going to paint the lateral surface area. So let's start. We chose a formula. Let's write down what it is. Okay. Do we have everything we need? Do we have R and do we have H? Pretty much. We pretty much do. 2 times pi times, don't get tricked, that's the diameter. Don't get tricked. Don't use 4. All right, now let's get an exact answer to start with. 2 times 8. I did not need my calculator. 32 pi, right? We're staying exact for now, but we're not going to stay exact for very long. How many tin cans do I need to cover? 25. At this point right here, I'm ready to leave exact in the dust. I am ready to find an approximate answer because I'm not going to go to Home Depot and be like, okay, so I need to cover 1,000 pi square inches. No, I'm not going to do that. I'm going to need to know the approximate answer with pi multiplied in. 32 times pi times 25. I have pressed the pi button. I have pressed the pi button. Okay. 2513.27. All right. That's how many square inches need to be covered. Now, we looked up online, and 1 pint covers, 100 square feet. This is in square feet, and this is in square feet. So since the units match, we're allowed to divide them. Divide this by 100, which is really moving the decimal place over twice. And we get 25.132. So what do you put on the test? How many cans do you need to buy? Good. Y'all all knew it. We need to buy 26 cans. If you write 25 on the quiz or the test, you'll get it wrong because you're going to leave 1 can and it's going to have a little bit that's not covered with that gold paint, and that bride's going to be really mad at you. So anyways, moral of the story, when it's a real world problem and you're buying supplies, you always go up. You don't use your rounding rules, you always go up.